53 practice on page 47. We're going to do a few of these. Solve the inequality and graph on a number line. So I don't need to distribute. I don't need to combine like terms, but I do need to try to isolate my variable. It's the only variable I have, so I'm going to try to get rid of the number that's being added or subtracted to it first. And I'm subtracting 4 from it, so I'm going to do the opposite and add 4 to both sides. Combine like terms, I'm going to bring down the 5x. Negative 4 plus 4 is 0, so I don't need to write that. Bring down the inequality symbol. Negative 4 plus 4 is 0. I know you get a 0, but that's okay. Next, I want to divide both sides by 5. That becomes a 1, and 1x or x is greater than 0. On a number line, I need to have 0, there's 1, there's negative 1, there's 2, there's negative 2. Greater than, so I need a hollow circle around 0. Greater, I'm going to shade everywhere to the right and shade in the arrow. 8, 10. I have a fraction, and I want to start by getting rid of that fraction, so I'm going to multiply everything on both sides of my inequality by the denominator 5. On the left, 5 times 8 is 40. Keep the inequality. I'm going to distribute this 5 through. 5 times 6 is 30. Keep the plus sign. Now here, if you multiply by the same number that's in the denominator of a fraction, they just divide out, and you're left with 2x. I want to add or subtract the number that's being added or subtracted to x, so that's this 30 here. It's on the same side as my variable. That's the one I want to move, so I'm going to do the opposite and subtract. 40 minus 30 is 10. Keep the inequality. 30 minus 30 is 0. I'm going to bring down the positive 2x. Next, divide both sides by 2. 5 is greater than x. Now, whenever you have your number coming first, it's hard to see how to graph on a number line. So you need to rearrange that with your variable listed first and your number listed second. But you can't just leave this inequality the same. I can see that my inequality, the small pointed side, is facing x, and so I need to write it that way here as well. I'm flipping this around, so you're flipping your inequality symbol around as well, just reversing the order. On my number line, I need a 5. Use a few numbers to the right, a couple to the left. Put a hollow circle around 5 because it's less than. Less means I shade, so I'm going to shade left where I thought the numbers are less than 5. And that's it. And then on number 11, that was 5 minus 3x is less than or equal to 8. I'm going to start by subtracting 5 from both sides. 5 minus 5 is 0. Bring down the negative 3x. Keep the inequality. 8 minus 5 is 3. Now I'm going to divide both sides by the number in front of x, meaning I'm going to divide both sides by negative 3. That's 1x. And I need to remember that when I divide by a negative, or multiply both sides by a negative, which I never did up here, but I am doing now, I need to change the direction of my inequality. 3 divided by negative 3 is negative 1. And I'm going to circle all those. And then I would put that on a number line. So I would find here's negative 1, 0, 1, there's negative 2. Solid circle on negative 1 because it does have an or equal to, greater than, so I'm going to shade to the right. Number 12, 3x minus 4 greater than or equal to 6x plus 11. Get your variable together first. So I have a variable on either side. I'm going to take the one with the smaller coefficient, this one here, and I'm going to subtract it from both sides. 3x minus 3x is 0. Bring down the negative 4. Keep the inequality. 6x minus 3x is 3x. Bring down the positive 11. Now I want to move the number that is on the same side as my variable, that's the 11. I want to move it away, so I'm going to do the opposite and subtract it. Combine like terms. Negative 4 minus 11 is negative 15. Keep the inequality symbol, bring down the 3x. 11 minus 11 is 0, so don't write anything there. 3 is the coefficient for x, so that's what I'm going to divide on both sides. Those divide out. Negative 15 divided by 3 is negative 5, so negative 5 is greater than or equal to x. I did not divide by a negative. The number in the denominator was positive 3. I divided by a positive number, so I did not change this. It's only when the denominator here that you're dividing by, when that's negative, that's when you change the inequality, not here. But I do need to rearrange this before I put it on a number line. So my inequality is pointing toward x. I'm going to leave it pointing toward x, and it had nor equal to on it. Number line, I need a negative 5. I need a couple numbers to the right, a couple of numbers to the left. Or equal to means I need a solid circle. Less than means I'm shading to the left where the numbers are smaller. And that's it on 12. Okay, 13 is very similar to 12. X minus 2 greater than or equal to negative 8x plus 16. I'm going to isolate my variable. My coefficients for x are positive 1, negative 8. Negative 8 is smaller. That's what I'm going to move. Do the opposite and add 8x to both sides of my inequality. X plus 8x is 9x. Bring down the negative 2. Keep the inequality. Negative 8x plus 8x is 0. Bring down the positive 16. Next, I want to get rid of the number that's nearest to my variable. That would be this negative 2. So I'm going to add it to both sides. Bring down the 9x. Negative 2 plus 2 is 0. Keep the inequality. 16 plus 2 is 18. Divide both sides by 9. Those divide out. X is greater than or equal to 2. Putting that on a number line. There's 2, 3, 4, 1, 0. Solid circle on 2 because of the or equal to. Greater, so I'm going to shade where all the numbers are greater, and that would be to the right here. Okay, and then I have another one, number 14. And number 14 has 3x minus 7 is less than 2 times 2x minus 1. 3x minus 7 is going to stay just like it is for now, but I do need to distribute because I have some grouping or some parentheses here. So 2 times 2x is 4x. 2 times negative 1 is negative 2. Isolate the variable by moving whatever coefficient is smaller. That's the 3x, so I'm going to subtract 3x from each side of my equation. 3x minus 3x is 0. I'm going to bring down the negative 7. Keep the less than. 4x minus 3x is 1x, or x. Bring down the negative 2. Next, I'm going to add that 2 to both sides to get it away from my x. Negative 7 plus 2 is negative 5. Keep the less than. Bring down the x. Negative 2 plus 2 is 0. I don't need to divide anything because I don't have a coefficient other than positive 1. But I do need to rearrange this. Now the open side is facing my x, so I'm going to leave that the same. Write the number line. Find negative 5. Go a couple of places to the right. And a couple of spots to the left. Does not have an or equal to, so I need a hollow circle. Greater than means I am shading to the right where my numbers are greater. Okay. Then there is number 15. 2 times 1/2 x minus 4 is less than negative and the quantity x minus 5. Now I know a lot of times we say when there are fractions you want to multiply by the denominator, but if a fraction is inside of something that needs to be distributed, then go ahead and distribute first, because sometimes that will get rid of the fraction for you, but sometimes it won't. So we're going to distribute first. 2 times 1/2 is 1, 1x is the same as x. 2 times negative 4 is negative 8. Keep the less than. A negative times an x is a negative x. And negative times a negative 5 is a positive 5. As you can see now, I have no more fractions. The smallest coefficient is this negative 1x, so I'm going to add it to both sides. X plus x is 2x. Bring down the negative 8. Keep the inequality. Negative x plus x is 0, so nothing needed here, but I am going to bring down the positive 5. Next, I want to add 8 to both sides to get it away from my x. Bring down that 2x. That's 0. Keep the less than. 5 plus 8 is 13. Now I can divide both sides by 2. X is less than 13 halves. I'm going to get that as a mixed number and as a decimal so I can look at it more than one way. If I say x is less than 13 halves and I want to split up 13 halves to get a mixed number, well, I know that 13 halves is 12 halves plus 1 half. 12 divided by 2 is 6, so x is less than 6 and a half. Well, 6 and a half is the same as 6.5. So my answer could be this, this, or this. All of those are acceptable forms of the right answer. When you graph, I can say maybe this is 6.5. So to the right of 6.5 is 7, to the left of 6.5 is 6. And then I'd have 7.5, to the left 5.5. So here would be my integers with the decimals in between. So at 6.5 or 6.5 or 13 halves, they're all less than, so I need a hollow circle since there's not an or equal to. Less, I'm shading to the left. All right, last one, like this, so 16, it's a little trickier. 2x minus 11, all divided by 3, is greater than or equal to negative x minus 2. So you have a fraction. When that happens, the first thing you need to do is get rid of the denominator. So we're going to do that. I'm going to multiply both sides by the denominator, that 3. When you have one big fraction with that denominator, they divide out and you don't have to distribute. That's different from up here. I had a fraction and then a separate term. Here I have one big fraction with 3 in the denominator. So those just divide out and I'm left with 2x minus 11. Keep the greater than or equal to. 3 multiplies by everything inside parentheses. So 3 times negative x is negative 3x. 3 times negative 2 is negative 6. I have a variable on both sides. That's the smaller coefficient. That's what I want to move by doing the opposite. So I'm going to add 3x to both sides. 2x plus 3x is 5x. Bring down the negative 11.
Attention please, if you drive
the
a silver
inequality.
Lexus and you're parked in the student lot.
Negative 3x plus 3x is 0. I'm going to bring down the negative 6. You still want to try to isolate that x, so it's the only thing there. I'm going to add 11 to both sides. Bring down the 5x. Negative 11 plus 11 is 0. Keep the inequality. Negative 6 plus 11 is 5. Divide both sides by 5. Those divide out. X is greater than or equal to positive 1. Now I want to put that on a number line. Here is 1, 2, 3, 0, negative 1. So I need a solid circle on 1 because it's an or equal to. Greater, I shade to the right. Just like that. I did sort of that one. Okay. Okay, last one, we're going to look at a word problem. Mayumi plans to buy pencils and a notebook at the school store. The pencil costs 15 cents and a notebook costs $1.49. Mayumi has $5. Which inequality could she use to find the number of pencils she can buy? Well, I'm not even going to look at those multiple choice options because I know that 5 is the total amount, and it's easier to think this much that I want to spend than the total amount than it is the other way around. So I'm going to cover that up for a moment. I'm going to write some notes as to what we know. So here's what we know. We know that a pencil is 15 cents. We know that a notebook is $1.49. And we know that the total amount of money available is $5. Now I know you cannot spend more than the amount of money you have. So when I say we have $5, I know that I can spend less than $5. I know that I can spend exactly $5. And I want to take that and I want to figure out an inequality that means that I can spend less than that amount and I can spend exactly that amount. Well, less than, there's actually a symbol for that. Less than. Spending exactly something means you're spending equal to that. So less than or equal to. I can spend less than or equal to $5. Now, what am I spending money on? Well, I am spending money on pencils and notebooks. So I need to find a way to put pencils and notebooks into what I'm spending since I know that that total amount has to be less than $5. So when I look back here, there's some very important information that's that can be very tricky to get. She wants to buy pencils, plural. So I know that she wants many pencils and a notebook. That means one notebook. She's only buying one notebook. Well, if I want to know the total amount she spends on a notebook, well, one notebook times $1.49 is $1.49. So when I think about pencils plus notebooks being less than or equal to 5, I know that I'm only adding 1.49 for my notebooks because that's all I'm spending on those. I don't know how much I'm spending on pencils. I'm not really sure. But I know each one costs 15 cents. And if I wanted the total amount that I'm spending on pencils at 15 cents each, I would multiply 0.15 by the number of pencils. But I don't know the number of pencils. And once you identify that thing that you don't know, that's going to be your variable. So I don't know the number of pencils. So what I do is I say, okay, that means I want to say, since I'm not sure what that is, I want to say let P be the number of pencils. And then the way you can write your inequalities, you can say, well, if I multiply 0.15 by P, I have the price of a pencil times the number of the pencils. That represents the total amount that you would spend on that, plus $1.45 for a notebook that you buy, which must be less than or equal to 5. And then you have your inequality. Now, you could also solve that inequality, which I know the question doesn't ask for, but we're going to try to do anyway, because I would like to know exactly how many pencils she really does buy. I'm going to pull this away. I'm going to rewrite that inequality up at the top. So we had 0.15p plus 1.45 is less than or equal to 5. And we know that P is the number of pencils. And we're going to figure that out. So to figure that out, we solve this inequality just like an equation. Now, normally I would start subtracting this number, but if you want to make your life a lot easier, if you have a problem that has decimals, you can multiply each side of your inequality, just like your equation, by 10 or 100 or 1,000 or a 1 with however many zeros you need to move the decimal place. So you need to move the decimal point 2 places to the right for this number and 2 places to the right for that number. So I need a 1 and 2 zeros, which means I'm going to multiply both sides by 100. Well, I have this grouped in parentheses, so I need to distribute the 100. And 100 will move a decimal point 2 places to the right. So 1, 2. That's where it's going to end up after the 15, which means I have 15.0 or just the number 15. That's a 15p. The next number, moving the decimal 1, 2 places to the right, gives me the number 145. Keep the inequality symbol. 5 times 100 is 500. Now it's like a regular equation, which is some rather large numbers, which is okay. Subtract 145 from both sides. Bring down the 15p. Keep the inequality symbol, and now subtract. So I can change this into a 49 and that into a 10 to help me subtract. So 10 minus 5 is 5. 9 minus 4 is 5. 4 minus 1 is 3. And then I need to divide both sides by 15. Okay, now this ends up with a p. That stays less than or equal to, and I need to figure out what that number is. So I'm going to first try some long division. 355 divided by 15. 15 does not go into 3, but 15 will go into 35 twice. 2 times 15 is 30. Subtract. 35 minus 30 is 5. Bring down that 5. 15 will go into 55 3 times, because 3 times 15 is 45. Subtract that, I'm left with a 10. I have a remainder of 10, so I write that as 10 over 15 as a fraction, like this. So I have 23 and 10 over 15, which I want to reduce. So 5 goes into both of those. So p is less than or equal to 23, and 10 divided by 5 is 2. 15 divided by 5 is 3. 23 and 2/3. Now, it's nice to have a mixed number here because I'm actually talking about a real-world problem, the number of pencils. If you just went ahead here and say, I know I can divide both of these by 5 as they're written now, and that would give me some other improper fraction that's all the way reduced, that wouldn't really tell me the number of pencils. So that's why I went ahead to do long division here, so I can find out how many whole pencils plus whatever other fractional amount I'd be able to afford. Now, you can't actually purchase 2/3 of a pencil. That doesn't really work. So on a number line, though, I can see here is 23. There's 24. To the left is 22. Break that into thirds. That would be 23 and 1/3. That would be 23 and 2/3. So this is where we are. Circle it in because it's an or equal to, less than, I shade to the left. So I can see from this, anywhere that's shaded, that represents how many pencils I could have purchased. Now, you can't actually realistically purchase that amount that's in here. So really, the most that I can get is 23. But I know I can purchase 23 pencils, 22 pencils, 21, 20, 19, 18, anywhere between 1 and 23 whole pencils, that's what I can buy. So since the 2/3 is not realistic, I'm going to say that, let's see, what was her name? Mayumi. Mayumi can purchase up to 23 pencils with some change to spare. Because I know that she can technically purchase a little bit more than 23. She has the money for it, but you can't purchase that many pencils. It's not realistic.